in this. All right, so we are doing linear programming and system of equations word problems today. The biggest thing with these is knowing the difference between the objective functions and the constraints. So constraints tend to be a word that kind of freaks people out. They're like, what are you talking about with constraints? It's restrictions on it. So if you think in terms of restrictions on the length of a table, all right, obviously we can't have the length of the table be -3 feet because, you know, that's not a thing. So we really can't, yeah, no. Unless you put axes marks on it, that doesn't work. All right, so we've got an example function. So the graph part's really just going to be for us to kind of visualize where we can actually have different pieces of info. Yeah. Yeah, this is how I make my videos. All right, so ready? Okay. So everything that we did yesterday is kind of coming back to haunt us, and I put that in air quotes for a reason. So I need every x value that is greater than 0. So if I'm looking at that, hang on, where's my little line tool? Line, we'll go red. Every x greater than 0 would be to the right of that, correct? Y is greater than 0. That would be everything greater than this. Now, there's a reason I'm not actually going through and coloring this yet. Because what I really care about is this final piece right here. The 2x plus y is less than or equal to 6. All right, so if I rearrange that, I've got y is less than or equal to -2x plus 6. So I can go up here at 6, down 2 over 1, down 2 over 1, blah, blah, blah. And now I can fill it in with my little line. Purple. Now, did we say that one is less than or greater than? Less than. So the entire shaded region that I'm really focused on is right in here, this triangle. So remember how yesterday we took the red and the blue and the purple and we kind of overlapped them? If we tried to do that on here, we would run out of space very quickly. All right. So when it comes to an objective function, they will typically tell you they want to maximize it or they want to minimize it. All right. You want to maximize profits, but you want to minimize your costs. Does that make sense? So you'll see this quite a bit within social studies with supply and demand or manufacturing or all kinds of boring crap like that. All right, so I don't know, what do we want to do? Maximize it or minimize it? Minimize? All right, you do need that information every time you do a problem because you don't know what you're really focused on. You don't know what you're looking for. It'll tell you in the problem. This one just doesn't, so I ask you. It will literally say it in the problem. All right, so what kind of points do we want to look at specifically to maximize it or minimize it? Any ideas? I would kind of use the vertices, because think about it this way. You've got infinitely many points in here, right? But typically, you've got your more major points here, here, and here. Those are your vertices. So I've got a vertice at 0, 0. I've got one at x is 3, y is 0. And then I've got one at x is 6, y is 0. Now the tables for me give me a more visual way of seeing, like, these are all of my options, which ones maximize or minimize. So what do you think I'm going to do with those x and y values and my objective function? Plug them in. So 0 plus 0 is 0. 9 plus 0 is 9. And then 18. So which one actually minimizes it? Yeah, 0, 0. This is my minimal value. So 0, 0 should be my answer. Two. Add them together. Yep. Oh, yeah, you're right. I put it in the wrong spot. So that makes that one 12. Does it really change anything, though? This is still my minimized value. So if you're looking for maximized, you would look at all your data points and look for which one's maximum. The 12. Yeah, the next one we do for sure is maximized. I can scroll just a touch. I would say it when I produce 0x and 0y, that's when it's minimized. Yeah. So for 12, it would be 0 and 6 as well. So when I produce 0 of whatever x is and 6 of whatever y is, that's when I maximize it. The points and what that maximum value is. To x, to y, and then what you get. Yeah, we could just circle that. Yeah. All right, ready for another one? I know my head's in the way. Shut up. I'm working on it. We're going to be maximizing this one. All right. Now, one of the difficulties with it, come on, you can write, is how do you figure out which x, y values do you pick? So I actually graphed this one on Desmos because when we were talking about it earlier today, kids were like, oh, well, you can pick 0 for x and 0 for y and then plug them in, and as long as they work, you're good. And I'm like, you're not wrong. Except if I plug 0 in for x and 0 in for y, what's 0 plus 0? 0. Is that greater than 12? No. Nope. So while it works for my first two constraints, these tend to be the more restrictive ones where you really have to focus more in on those. Okay? So while 0, 0 works for my first two, it fails that third one. Every number you pick up here, or every set of numbers that you pick up here, have to work for all four of your constraints. Does that make sense? Kind of, sort of? A little bit? So, because Desmos is a wonderful thing with this. So what I'll probably end up doing on the test is I'll give you one of these, and instead of me giving you a question from yesterday, like, just graph these two equations and then color it in. This would be like 6.5 and 6.6 combined. So you would only have one of these with linear programming, and you would have to graph it as well. All right? So the reason I teach you 6.5 is so we can do this crap. So why would I give you an additional question on 6.5 if I could just give you one on this, and then I know if you know your 6.5 stuff. Big brain. So, oh crap and a cracker. If I look at this, I've got, what, 5 points I can pick from? So 0, 4, 0, 5, 2.5 and 5, 6, 0, and 10, 0. So could we write those in on our table real quick? So write the x's and y's. Yeah, they're warheads. That's how they're supposed to be. All right, you got your tables written in? Yeah. All right, can I scroll up again? Yeah. So, what were some of my points? 0, 0, 5, 0, 4, 6, 0, 2.5, 5. 2.5. All right. So now I got to plug everything in up here. Yes? So this one's 45. This one's 36. This one's 54. This one's 90. And somebody with a calculator, can we hit that last one? I know it's 45 and then half of 45. Yep, 67.5.
Girl.
So which one actually maximizes this function? 10, 0. So when I go to look at my answer, yes, no? So they give me these restrictions, right? These restrictions give me this pretty picture. The vertices give me where to plug it in. And then my objective function, which is this 9x plus 9y, helps me figure out, okay, which one actually maximizes it. This one. Yeah. All right. I just type in these four. I just type in the constraints. And then I go through and make my table and... All right, ready for another one? I was going to say, this one ain't too bad. So I would kind of sketch this in, and I would try this one with a neighbor. Ready? Well, hurry up. So I've got 1, 3. I've got 3, 1. I've got 3, 5. And I've got 5, 3. Sure.
Okay. 1, 3 is 16. 3, 1 is 24. 3, 5 is 36. And 5, 3 is 50.
Yay?
Yeah.
So this one maximizes it. Score. All right, I got 2 more examples and we'll be done. Because we're not doing any notes tomorrow.
No, word problems.
Yes!
No.
It said word problems. You're gonna be fine. There's everyone who's gonna throw a hissy fit. So for this, the biggest thing that I really care about is they make $2 for profit for part A, and they make $6 for profit on part B. And then it'll tell you either in the actual paragraph or off to the side, make X for part A, make Y for part B. All right. Ready to make a profit function? No, not yet. Okay. Okie dokie. No, I'll do it with you. And you're like, yes. So you can just toss the pluggy end to Sophia, and Sophia can reach over and plug it in. There's a power strip now Velcroed right over there. Okay, we're ready? So, of all of the words that are up here, what do I really care about? $2 for part A, so 2 for X. 2X plus, how much do I make for part B? 6 times however many parts I make, and this is going to equal my profit. Objective function.
That's it?
That's it.
Oh my god.
It's not too easy. That's all I asked you to do. Boom, answer. 1 more problem. I told you there were 2 more. I know, we're almost there. Wait. Okay, can I scroll? No, you're okay. Now can I scroll? All right, so this is just a general word problem. I highly recommend just writing the whole stupid thing down. Oh God, it's the last one. Chill out. You can write 3 sentences. So for this one, this is just a general system of equation words problems, okay? You're not doing linear programming with it, so you don't have to go through and make the whole stupid table. All right? So it says the perimeter of a rectangle is 46 meters. All right, how do I find the perimeter of a rectangle? I add them up. So I would have perimeter equals 2L plus 2W, right? So for my first equation, it's 46 equals 2L plus 2W. I know. All right, now for the second equation, it says that the width is doubled and the length is increased by 12. So what does that even mean? Yes. So I've got my new perimeter equals width times 4, so 4W, and then it's 2, and my new length is going to be L plus 12. All right, so I'm taking my original one, I'm adding 12 to all of my lengths, and then I'm doubling the width. Well, when you double the width and you're already multiplying it by 2, you make it a 4. Okie dokie. So they tell me that this equals 82 now. So 82 equals 2 L plus 12 plus 4W. How many of us are still panicking?
No, I'm good.
We're good? Those would be your 2 equations. So we're going to end up creating, because it's a system, and I'm going to solve. Are they already what?
Are they our constraints?
These are not constraints. This is just, earlier in the unit, remember when we had x and y, and you were just solving for x and y? That's what you're doing here. All right, so, guys, when it comes to actually working these out, the recommendation I have is to kind of manipulate this 82 one. So 82 equals 2L plus 24 plus 4W. All right, the reason I want to manipulate that one is because it's ugly and I can get it into elimination format so I can cross crap out, right? So what is 82 minus 24? $58. So this becomes 58 equals 2L plus 4W. So I would just, I know, hang on. Yeah, because now I can do elimination. I just need them to be something L plus or minus something with W, and then all the number crap on the other side. Yeah. So, when it actually comes time to solve, what do you want to eliminate, the L's or the W's? I'd go L's. So I've got 58 equals 2L plus 4W. And then I've got my other one, which was, what, 46? But I need one of them to be a negative, so I'm just going to change that original equation. So negative 46 equals negative 2L minus 2W. Now easier, because now my L's cancel. Will equals 2W, W equals 6. I can plug that back in, and my length is 17. Yeah, because 17 times 2 is 34. 34 plus 12 gives me 46, so I'm good. Yeah, it's not that hard. The problem is once you start looking at everything and you're like, linear programming, everything becomes linear programming. And I'm like, no, that's still a thing. We can do that. Other side note is on your homework. There's one where it's a system. And it's x squared plus y squared equals 100. And then like x plus y equals 7 or something like that. I'm just making up numbers. And it says solve it with substitution. You can just screw with the second equation. No, that's illegal. You can't do that. Yeah. You're just trying to square root everything. Yeah, I would rewrite this as y equals like -7 plus that. Yeah, negative x plus 7. And I would take this and plug it in up here and then solve. Because that first graph is actually a circle. All right, so you're going to have two solutions on it. So try substitution. If substitution gets real icky, graph it and see where it intersects. Okay? One like that would end up showing up on a graphing open part for your test. So you could use your graphing calculator and type it in and be good to go. Bueno? I'm done.